Looking at the data set that we've been looking at before, we're going to look at two different variables. So we had been using drinks to try to predict GPA before, but now let's try to use drinks to predict classes missed, which is the number of classes missed in the semester. We have some output for that linear fit between drinks and trying to predict classes missed. So first what we want to do is write out our equation, use it to predict the residual value for someone who drinks 6 drinks and has missed 2 classes. So our model we can write out from the estimate column. Our intercept is 1.864, so we get y hat equal 1.864 plus our slope of 0.062 times x. What we want to do then is we have an x of 6 and a y of 2. So to get our predicted value, we plug 6 into our equation, and so what we'll get for that is 2.236. So the person who has 6 alcoholic drinks is expected to miss 2.236 classes. The student missed 2, so that's the y. So when we take y minus y hat, that difference is our residual. So we get negative 0.236. And this is something we did back in chapter 2. We also interpreted the slope in chapter 2. So the slope idea is as x goes up 1, it's the change in our y, and we want to put that in context. So here, for each additional drink, which is our x, we'd expect the number of classes missed to increase by the slope of 0.062. A new thing then to this chapter is to look at a test to see if there's a significant positive relationship. This would be in the population. Because we're checking for a positive relationship, our alternative will be greater than 0. So our slope equals 0 means no relationship. For our null, our alternative is a positive relationship. In our table, we would be able to get this missing spot here of our test statistic by taking our slope divided by its standard error. And if you do that, you get 1.24. You could look that up in StatKey using a right-tailed test with degrees of freedom of 251 like in the other ones. Or we can notice that we are given a p-value here. This p-value, 0.2164 that we are given, is two-sided. That will be how the output is in SPSS. We are not doing a two-sided test, so we actually need to chop this back in half. It has been doubled, but we didn't want to double it. So we get 0.1082 for our p-value. That being greater than 0.05, we would fail to reject our null, and we would say then after that we do not have significant relationship or significant evidence of a positive linear relationship between drinks and classes missed in the population. R squared, because we are doing a linear fit, can be obtained by squaring R, and that will give us 0.00608. Notice that is very close to 0. This is lower than the earlier R squared when we were looking at GPA with drinks instead of drinks and classes missed. And so do drinks better explain GPA or classes missed? Our answer there is GPA. GPA was explained better due to a higher value of R squared, even though it was not very high either.